Theme. So rewrite each question as requested. So we're rewriting a logarithm as exponential and an exponential as a logarithmic. I'm going to start with this logarithmic expression because then it'll help explain the first one a little more clearly. So this is what I call more of a, I call it the log dance because that's what we're doing with, we're taking inverse functions, right? So if you had 2 plus 3 equals 5, and you wanted the inverse operation, what are you going to get? You're going to move one to the other side. So, so you're thinking subtraction is the inverse of addition. So you could rewrite this as 2 equals 5 minus 3, right? Because it's one way to think about it. Okay. So if we had a variable, let's go with like x plus 3 equals 5. How do we solve it? We do the inverse and we get x equals 5 minus 3. So notice there were two items that were on one side together. And when we get the inverse, those two are going to be split apart, right? The x and the 3 are going to be on opposite sides. And the one that was by itself, the 5, now has a partner. Okay, so it's kind of, that's how it's going to divide up. When we think in terms of exponentials, their inverse is a logarithmic function. So here's how the log dance works, is that the two things that are together, the e and the 7, they're going to split apart. Okay. Now we've got to know the way it is. We're going to get a logarithm because that's the inverse, just like subtraction is the inverse of addition. So you have to know the right symbols. You just have to remember log is the inverse of e. The base of the logarithm, the base of the exponential is e. It's holding up the exponent, right? That becomes the base on the logarithm. Now notice the e in this, and then there's going to be something input into the logarithm, and there's going to be something over here. Well, the e and the 7 are currently together, so as an inverse, they're going to switch. E is not going to be with the 7. The 7's got to be over here. So where does the y go? It goes into the only place that's left for it to go, which is as an input. Now, log base e has a special symbol. Log base 10 also has a special symbol. It's the one with where you would just write log without, if there's no base listed, it's a base 10. Okay, so that's called the common logarithm. This is the natural logarithm. It's called natural log. And so we can write log base e as ln. And it's ln, you're thinking, that doesn't seem like natural logarithm, it seems backwards, but it comes from the French. In French, they would say logarithm naturel, something like that. I'm not real fluent in, I don't know French. I am part French through my mother, but she knew a little French. I don't. So anyway, natural log of y is equal to 7. That's what we're going to write for b. And I wanted to do this one first because by explaining that, natural log y equals 7, hopefully it will make this one understandable, right? We'll do it in blue. So ln is the same thing as log base e, x equals 4. And we just do the log dance. E is the base, so that's going to be the exponential. Get rid of this stuff. So I just wanted you to see a case where it worked in general. Let's get rid of this just to kind of understand what's going on. So the log exponentials are the inverse of logarithms. So this is going to become e to some power. But notice the e and the x are together, so they're going to split. The x has to come over here. The 4 was by itself. It needs a partner, and it partners with the base. It becomes the exponent. So in this way, you're thinking every log question, the answer to a log question is an exponent, right? This 4 is the exponent that goes on the e that gives us this. And we've actually solved this equation, but this is what we're going to enter in. So we're going to put in e raised to the 4th power arrow equals x. Okay, so that's what I call the log dance. But notice in both cases it has, well, it's not in both cases. In this top case, we've used it to solve for x, because we can now x is equal to e to the 4th. We could plug this in our calculator, get a number. We have solved for x. In this other one, it was already solved for whatever y was solved for the variable. But now we've got an equation where we could, we don't know what y is, right? We'd have to solve. So generally, we use it to solve for the variable. But yeah, thank you. We'll leave it there for now.